Here are the notes for exponential growth and decay. Uh, may not have it with a full teaching video, but just in case you're filling in your notes, you can pause the video, copy down what was done. Of course, hearing it is better. Here was the logistic growth and looks like we're doing some continuous growth. Then the homework on that was the odds. You see a couple answers that we did. Hopefully they're looking good. That way everybody can see another application of exponential functions. We're going to talk about compound interest, which usually implies money that you are making. When I say compound, it's like this, guys. You put money in a bank, you put $100. And yoo-hoo, the end of the year, the bank gives you $10. So now you have 110. So obviously it paid me 10% for the year, right? But how much is it giving me, if it gave me 10 this time, how much am I getting next time? Am I getting another 10? No. I'm getting 10% of 110. I'm getting plus 11. That's why it's compound. You're making interest on the previous interest. So now I'm sitting at $121. At the end of that year, what do I make? Another approximately $12.10. I only got 10 one year. Now I got 11. Now I got 12.10. Look at that. It only jumped $1, but now it's jumped $1.10. It's always going to keep jumping more and more and more. Okay? That's why it's called compound. The formula will be the amount of money you'll have in the future is equal to the amount of money, I'm going to call the word principal, that you put in, parenthesis, and it's the same thing as, it could be a growth or decay. And so when I go 1, it could be a plus or it could be a minus depending on is it growing or is it decaying. That car, that truck that Daniel did the calculation on, it was losing money. It was losing money. So that would be a decay. If you invested your money in, well, I heard there's a new company that is making whips for horse and buggies, because they really think that people are going to go back to riding horse and buggies. So a lot of people recently invested a lot of money into the whip company. Got bad news for them. They're losing money. No one's buying whips for horse and buggies. So that's a decay. So they're losing money. And then when we do the interest rate or rate of change or rate of growth, it's kind of like the half-life problem. That every time a certain number of years or days or months go by, we have to figure out how much changed. We call that number the letter N, and it stands for the number of times, we'll label over there, that we compound in that time period. Raised to the, instead of RT, it's NT. The same N that I put here, I put next to the time. So let's try to define these. I had a hard time in second period to define N. I still really don't think I have a great definition, but A stands for the amount in the future. P stands for the principal. And this is the amount invested. Or it's the initial amount maybe it's not an investment. Maybe it's, R is the rate of growth, or in money, we don't usually say decay. We usually call it depreciation. Have you heard of that word? Well, I said it earlier. Depreciation. Mobile homes depreciate. A brick home, a wooden home, appreciates. They make money. Mobile homes, they're like boats. They're money pits. N is the number of times, and I said it good a minute ago. The number of times that we compound, in the time frame. Okay, you'll see what happens, why that changes. And T stands for usually time, but usually we say years. Money's usually invested for years. It's not usually invested for months. But you can still do the math and you can calculate it. Let's say you change your mind. I'm only investing for 4 months instead of the full year. You could do calculations. So let's do a couple problems, see how this works. Some of you have done these before. It literally is something that we have taught in middle school. And if you took the financial literacy class, you may have done some of this. Do some examples. Dave invests only $300 in an account. The interest is only 5%. FYI, I still need to call that 0.05. And he's going to make got the hiccups. No other deposits or withdrawals. So the money's going to sit there in this account collecting dust. But fortunately, because there's a 5% interest, it's also collecting some change. And he's going to keep that there for at least 15 years. We're going to find out how much he has. Okay? So there's a way that we can say that the money is going to be compounded semi-annually. What does semi-annually mean? Does anybody have a clue?
Every 6 months.
Every 6 months. So here's the question I have for you. Now, somebody this morning said, half a year. I said, great. Then if we're talking about investing in per year, I'm going to find out what I have. The question I asked the class, and nobody could tell me, is my N will tell me how many semi-annuals will be in a year.
2.
Thank you. 2. That means 2 times a year, the bank is going to press a button and say, ka-ching, here's more money for you. 2 times a year.
And it's going to be a larger amount than the monthly amount.
Oh, you want to start talking about compounding monthly? We're going to go there.
Yeah.
What are you thinking? What do you think? It'd be better to do it semi-annual or better to do it monthly?
It depends on the interest rate.
What if the interest never changes? Interest rate's the same, 5%.
Then monthly.
Monthly. You think monthly is better? Why?
Because it's the change is being added monthly instead of every 6 months. It'll be the same amount though. Am I wrong?
No, you're right. You're going to make more money. Because instead of waiting till June to get some interest off the money you put in, you'll get some interest in January. Now, January, you have more money than you had before. So February comes along and you're going to get 5% of the total now. So you're going to get more on top of the interest. Good job. Good thinking. So here's the formula. I always like to do one formula with the T will equal to, we're putting in $300, and it's definitely a growth. 1 plus my 0.05 divided by, what's my n? 2. Raised to the 2t power. Notice again, this has a t, so there should be a t up here. Sometimes I get lazy and I just do it all in one step, but I'm trying to show you the difference between having an equation and then using the equation. Because now I'm going to use it for how many years? 15. So that's going to be 300. 1 plus, can you do 0.05 divided by 2 in your head? And it's okay if you can't. You could just leave it there and put it in your calculator, but I think some of us could divide that by 2. Make it easier to key in your calculator. Is it 0.025? Raised to the 2 times the 15. Oh, I can even simplify it again. Watch, equals to 300. 1 plus 0.025 is 1.025. And then 2 times 15 is 30. So I always think it's nice to try to simplify as much as you can before you type it in. It might save you pressing buttons. Before I ask you for the approximated answer, because this is the exact answer, and now I'm going to do the approximate. How do I know this is a growth based on looking at it? The what? Talk loud. What's greater than 1? The what?
Oh, never mind. My bad. Yeah, the rate, yeah.
Well, no. The rate's actually not bigger than 1. The rate was only 0.05.
And when it's raised to? Yeah.
The what?
When it's raised to?
Well, that'll should always be bigger than a 1 unless it's
I thought it's like whatever's in parentheses.
Oh, what's in parentheses?
Yeah.
What is this called? The base.
Yeah, there you go.
Yeah. The base is bigger than 1. Okay, now, time for the calculator. Let me give a second here. $629. Make sure you use a dollar sign. How many cents did I say? 27. Now, we're going to compare this semi-annual calculation to monthly. Okay? That's what Christian was talking about. What would N be now? 12. The formula is the same almost. A of t is now equal to 300 times 1 plus 0.05. This time it's divided by what? 12. And I can't do that in my head. So I might be forced to leave that the way it is. And I'm raising it to the NT, which should be 12T. So again, I'll ask you the question, how long am I investing it for? All right, so A of 15 will be 300. Whatever 1 plus 0.05 divided by 12 is, raised to the 12 times the 15. And again, I'm not sure what 12 times 15 is in my head. I could probably do it 150 plus 30, 180. Oh, okay. I did do it in my head, but it hurt my head a little bit. I kind of got like a brain freeze. So we could call that 180. So in my calculator, I'm going to get an estimate. So let's do this one together again, and we'll see what we get. I might forget those numbers, so you might have to help me. Surprise, surprise, $634.11. So went from $629 to $634, roughly, what, $5? Now you might be saying, that's not very much money to care. Something is something. My wife always says that. Something is something.
Mr. Cartwright,
Yes.
can I go to that last chart?
Yes, ma'am. If $2,500 is deposited into a savings account that is earning 8%, which is, by the way, 0.08 is a decimal, and is annual. Annual means for the year, the annual interest. You've heard the term APR? When you see APR, you're buying a car, buying something. APR means annual percentage rate. Okay? Annual percentage rate. How much will be in the account at the end of 25 years if the interest is compounded and we're doing it by quarterly? So we're still talking about annual interest rate. So we're still talking about the time periods a year. How many times would I be compounding if it's quarterly? What do you think quarters mean? 4. When I do the other one daily, what do you think n will be?
4.
Only one person this morning knew the answer. Got to give it up to Alex. She's the only one.
Like how many days in a year?
Yeah.
365.
Oh, but this morning I couldn't get that many people to tell me, so good. 365. So that means a bank is paying you interest every single day. Nice, right? So let's see what this gives me. A of t will be $2,500 times 1 plus, my interest rate was 8%, so 0.08, divided by my n, which is 4, raised to the 4 times, how many years were we doing? 25. 4 times 25. I could simplify that probably as 2,500, 1 plus, I could do this in my head, 0.08 divided by 4, because 4 only goes into 8 twice. That's 0.02. And then 4 times 25 is 100. And if I'm really, I can now talk about, I'll simplify the next step at the same time as doing the work. A of 30, no, 25 will be 2,500 times 1.02, if I add those together, raised to the 100. All right, so let's see how much money. Somebody, tell me. This time you're going to do it. I'm not going to.
It's 18,111.6.
18,111.6.
62.
We're talking about money.
Dollars.
Point, yeah, and
62.
60. Oh, it is 62?
It's 61, but after the one it has a 5.
Yeah, okay, 62 cents. So we started out with only 2,500, and we're up to over $18,000. You see the power of compounded interest?
Yeah, so that's 25 years.
That is 25 years. So you're putting that money away and not touching it. That's kind of hard to do. Let's see if we do it daily. Theoretically, based on the logic, you get up in the morning and the bank's paid interest. You get up the next morning, the bank's paid you interest. You get up in the morning 365 times. Surely I'll be making more money. Let's see how much more. A of t will still be the 2,500. I'm still going to have the 1 plus, but the 0.08 now is divided by 365, which I'm not even going to pretend to do the math. And you shouldn't type it in and then round your answer here to 2 or 3 decimals, because then you're going to lose money. Raised to the 365 times how many years?
27.
It's still 25 years. Okay? So let's go ahead and key that directly the way it is, because simplifying it would be kind of hurt my head a little bit. So hopefully some of you have already keyed it in. Why wait for me? Some of you are better than me. Just do it. But you can tell us if $18,468.59. Was it more than I had?
Yes.
Yeah, it was 111 versus 468. So it was over $300 more. I mean, it didn't cost you any more work. You still kept the money in the bank for 25 years. So what bank are you going to go to? The bank that does it daily or the bank that does it monthly? May as well, right? Okay. I like this problem, but I'm kind of getting tired of these because I want to move on. But when Amelia turned 6, what a nice grandparent she had. They started a college fund, a college savings account. And the initial deposit was, well, not very much. It was only $500. The interest that was being earned was 3.2%. So reminding you what that has to be, that's 0.032, okay? It's compounded bi-monthly. Bi-monthly. I'm still talking about a year because that's still annual interest. So what would N be with bi-monthly? That's what some people thought this morning. It was 6.
Bi-monthly, twice a month.
Yeah.
And it's
Oh, twice.
24.
Oh.
See, you fell in the trap, Christian.
That's my.
And it's 24. Twice a month, 12 months. Yep. And matter of fact, I actually scratched my head and I said to myself, can somebody Google bi-monthly? Because I've never used bi-monthly before. So, and let's see, the grandparents make no other deposits or withdrawals. How much money will she have at 18? So here's my thought. Stop me if you disagree. The amount of money, I keep messing that up. The amount of money in the future will be that $500 times 1 plus, I did the interest rate as 0.032, so let me get that one correct. 0.032 divided by that 24, all raised to that 24t. Okay? Does that look good so far? All right, keep paying attention here. I want to find out how much money I'm going to have in 18 years. Huh? You don't like my 18?
No,
She said she's going to be 18 years old. It says there right there.
but they said when she was 6.
Oh, she didn't start getting the money in the account till she was 6. Thanks, Diana. 12. Yep, it's going to be a 12. So that would equal to 500, 1 plus whatever this number is. I'm not going to key it in and find out what that approximates because that'll mess up your answer. And 124 times the 12 years. And I'm going to key that in. I'm just going to key it in straight across to find out what the answer will be approximately. Or let you do it, somebody. You do it. Somebody tell me. Give me a break. My finger's hurting. Who can I pick on? Are you using a calculator, Victoria?
Yeah.
Because in this classroom, I think you are the calculator queen. You did stuff on that in Inspire for your test. It was out of this world. And I know you put a little note for me. And I understand. Did you key this one in, Victoria?
Yeah.
What do you think you got? Better be more than $500.
It's 22,000.
What? 20 what?
22,000.
22,000?
That's where I think you're confusing everyone because you put 124 instead of just 24.
Oh. Oh.
Oh,
I was trying to trick Victoria. Did it work?
No.
It didn't. Did you use 24 or 124?
I did 24.
Yeah, I meant 24. I was making a parenthesis, and I think I changed my mind. You use the 24?
Yeah, I did 24.
Oh. So you didn't get this answer, Dardiana? 22,000 something?
No.
Uh-oh. Did anybody?
Yeah, I probably keyed it in.
Okay. Did somebody else want to see? We'll see how different it is.
700.
How many?
733 with
700?
33
733?
with 88 cents.
How many?
wait, 700? Oh,
What?
no, I thought it was 700,000. I was like, there's no way.
No, 700,000 would be way too much. 733 is, she's saying $733. And how many pennies? 88. Well, we got to break the tie, unless Victoria found a mistake, or did anybody else get the 733 number? Okay, I got somebody here. Just one person? Lorena, what did you get? Did you key it in? Victoria, did you fix it yet?
Yeah, I like putting like the result for like 0.32 divided by 24.
Oh,
Like I put in the decimal.
no, I said you can't do that.
No?
No, because chances are you're gonna if you do these intermediate steps, it will never be accurate. Yours was way off though. 22,000 was a lot different than 733. So, is it working now? Did you get it to work?
No, I don't know. I don't know.
Okay, key it in with me at the same time. Right. Let's see. I'll skip these two. Maybe you should just do them yourselves, guys. But I'm gonna jump down to continuous compound. Do you remember what continuous meant? Say it again?
You constantly get money.
Constantly, right? It takes a computer to do it. It's like this. You get interest. You get interest. You get interest. You get interest. That's not even fast enough. You get interest. You get interest. You get interest. You get interest. Just constantly paying you interest for every millisecond of time. So if you think about it, my n is actually infinity because it's an infinity number of times. And in calculus, we actually do a problem of compound interest with n approaching infinity, and we actually derive the equation that we're going to use right now, okay? In some cases, the interest is compounded continuously, meaning the account is collecting interest constantly. The formula should look very familiar, I think. Matter of fact, I really want to go look it up, make sure I key it in right. You know what? I'm going to go look it up, make sure. I want you to do number 4 with your partner. It should take you 5 minutes to do number 4. And if everybody gets it right, I'll add another 10 points to that homework grade. Okay, what do we get? How much would we have earned in 10 years? Hello?
780.58 cents.
Started out with $750, right? What do we have at the end?
780.58 cents.
780 point what?
58.
58? Do you think that's the answer they're asking for?
Yep. Yeah.
Actually, that's not. She did not earn that. How much interest will she have earned? You have to take that 788.58 and you have to subtract the original $750.
30.38.
30 point what?
88 cents.
Yeah. So that was a trick question. You did really good. Don't get me wrong. You did good. You found out how much you were going to make. All right. Back to this. The reason I got confused is because we had this formula before. It was the shampoo formula. The amount of money in the future was equal to the amount of money we put in. Continuous means base E raised to the RT power. Why is there no N? Because it's continuous. Could you count it? No. Because N is really technically approaching infinity, right? So we don't need it because E already takes into account the number of computations there are. So suppose that you invest $800 in account with 6% interest rate compounded continuously. And we're still pretending it's APR, but it doesn't really matter. The key is continuously. If no other withdrawals or deposits occur, find your balance after 20 years. Piece of cake, just like the homework you had earlier. A of T will be equal to the amount of money I start out with, 800. E, interest rate is 0.06 times the 20. That's the exact answer. You want to clean that up a little bit? I'm not going to clean it up. I'm just going to go to the calculator. Key it in, please. It's got to be more than 800. Holy cow, how much? 2,656? I thought I said 55. 56? How much change? 70?
9 cents. Just like 0.09.
Oh, 09. Why so much money?
Because it's constantly,
All right, because it's continuously. Is that the main reason? Or does it help that that money was staying there for 20 years?
the 20 years definitely does help. Right?
Definitely does help. Because we could compare this. Let's, for fun, compare this to just collecting interest once a year and compare it to the amount of money in the future being 800 times 1 plus the interest rate, which was, again, it was 0.06. And let me compound it once. That means divide by 1, raised to 1 times 20, or 20. Let's compare this. This would be 800, 1.06 raised to 20. This is just standard banking, compounding interest, but not continuously, compounding one time. I'm just curious if there's a big difference. I'm thinking out loud. Anybody calculate that? Approximately what? Could it possibly be close to $2,600? Nobody keyed it in? Jerry, did you key it in? What you got? 2,565? 71 cents. All right, compare it. It was 2,656, right? Versus 256. 2,565. 25. Yeah, $100 or so, right? Not as much as I thought it was going to be. But something is something. All right, find the balance of an account after 5 years if you are using $1,200 initially. Interest rate is 12.5%. I got to remind you, that means 0.125. We're compounding continuously, and there's no other deposits. We're going for 5 years. So the amount of money in the future should be that big amount of money, 1,200. E raised to the 0.125, and the number of years is how many? 5. So the approximate answer is, help me out here, 2241 with 90 cents. Money sign. All right. Good enough. What was this one here? Oh, he wants you to compare two options and check it out. That means you're basically doing two problems, which is what you would really do in real life, guys. When you're investing, you would probably compare the numbers from two different investments. That's not a bad problem. Might save that for a quiz problem. This is your work. Let's see, how much work is on this? There's 5. Just 2? Now, I'll tell you what. I want you to do number 1 and 2. Compare those different things. And
That's like 4 within it.
it is. But you can handle it. 3 and 4. And how many you want? Second page, do 2 of these continuous. Yep. And I got bad news for you. I think I'm out of applications that we're going to do for exponential growth. I got to talk to Mr. Dotery. But I think we're probably going to call it quits on exponential functions, and we'll be starting trig maybe the next time we meet.
Oh, so are we taking a quiz or what?
You'll still have probably a quiz on these applications. I don't know if I'll do the quiz next time or the time after, but yes, Lorena. Depends what time it is. Yep, you are in the right time frame. So what I need you to do while we got 15 more minutes is work a problem or two with your neighbors, okay?